Hello students, now we are going to continue with the same numerical part of it, of center of mass. But before I go into the center of mass, I would like to draw your attention about why do we mean about center of mass? What is the necessity of it? So, if you take a car which is nicely built, and it is going to go in the road which is fully ready now, but remember, the car has to be in a balance. That's the reason they say balancing of the wheels and everything. If the car is not in balance position, you will not be able to really go in a proper direction, and as well as it will not be comfortable to ride also. So this car will have its center place where the entire mass also could be concentrated. So that's the reason whenever you go to the garage, there is one central huge pillar will come, and they can lift the whole car. Have you seen that one? The whole car will be lifted up, and they will be able to wash it. Somebody is going to go down and then repairing it, all these things. At the center of mass, they lift it, and they will be able to balance it also. Whenever you make it as a kind of a center of mass, the very important word called balance will come. So a tiny mass, a little bigger mass, such a bigger mass which was there. Yesterday we saw that one. M, 2m and 3m. It could be three different sizes of mass also, but this will have a center of mass somewhere here. And that point will balance everything. You put a force on the top of this, and the entire thing will be able to be on a balance. So balancing is there only when you are there operating at the center. I would tell also about a human life. When we have our life, many times we will not be able to really go in a right direction because we are not in balance. Either we are too much into certain things, maybe these days mobile phone, you are too much into mobile phones, or sometimes you are too much into worries, or you are too much into several other practice of life, but there is no balance. So, how to bring balance is, you define the center. Unless you define the center, you cannot bring balance. So in a life cycle, in a life, there are so many areas are there. Friends, and then gadgets, studies, and future, your family, parents, and all of them. So they have so many things there. But remember, define the center. If you don't define the center, you will be going around and round and round. Either you'll be too much gadgets friendly, or too much friends friendly, or you too much studies is a last part sometimes, most of the time. Oh, it's okay, we do it later on. Or many of them you are worrying about the future. Some of them your family is really going through difficulties, whatever it is. But define the center. Center is so important. And center place, it revolves, or it especially pins on the main person of God himself. That's the center of life. Unless you define God, rest everything will not be in balance. It will be all going hayway. So make a prayer to God, saying that, God, I want you to be the center of my life. Let you be the center of my life. I don't want to go in any other direction, here and there, and lose the balance. Let God be the center of your life. And God will help not to get too much engaged with anything else, but God alone. And that will be the center. Your life will go smoothly in a highway with nice pace, with nice way in everything, because God will define the center. Now, center of mass will always depends on balance, and it depends on how much you have located the center of mass, right? Today also we are going to locate center of mass into numericals. We are going to find where is the center of mass of these bodies. So try to understand, whenever you look at a body, where is the center of this one? Which location could be the center? That's the way we are going to have. So turn to page number 406. Question number 3. There are 3 bodies are given there. This is 1 gram, 2 grams, 3 grams. And these bodies are kept in a nice X and Y axis plane, which for comfort, for easiness, for locating it, we are putting it in a axis point of view. So 1 gram is here, and then this is little more bigger, and the next is little more. So this is 2 grams, this is 3 grams. And all of them are kept on an equilateral triangle vertex. So look at the center of mass of this bodies in equilateral triangle, 1 meter. This is 1 meter, this is 1 meter, this is also 1 meter. It's an equilateral triangle. So we keep it by X and Y axis plane, so that it will be easy for us to locate every mass in an XY coordinate. Right? So first of all, M1 is equal to 1 gram, M2 is equal to 2 grams, M3 is going to be equal to 3 grams. And also, what is X1 and what is Y1? What is X2, Y2, X3 and Y3? You need to locate this. Now here it is 0, 0. So X1 also it is 0, Y1 also 0. These two are 0, 0. Here you will find x-axis is 1 meter, but y-axis is 0. So it is 1, 0. So x-axis is 1 meter and y-axis is 0. Now if you look at this, this is at 1 meter above, or what is this? What is this height? What is this height? This is under root 3 meter will be there. Under root 3. Right? And from here to here it is 0.5. So in x-axis it is 0.5 meter, and this is under root 3 meters. Right? So you got all this ready? x1, y1, x2, y2, x3, y3, and m1, m2, m3 is there. So we need to find out the x value. When you want to find the x value, m1 x1 plus m2 x2 plus m3 x3 divided by m1 plus m2 plus m3. And also y is going to be equal to m1 y1 plus m2 y2 plus m3 y3 upon m1 plus m2 plus m3. Now just keep on putting this value. This entire value you put this one. So 1 into 0 plus 2 into 1 plus 3 into 0.5. This is all there. This one, this one, this one. Here, here, here. Divided by 1 plus 2 plus 3. Now what will be the answer here? 2 and 1.5. 2 plus 1.5. 2 plus 1.5 divided by 6. So it's going to be equal to 3.5 upon 6 is the x value. Put it also here. So again 1 into 0 plus 2 into again 0 plus 3 into under root 3 plus upon 6, same thing will be there. So 3 under root 3 upon 6. So if you do it, it will become under root 3 by 2. That's why. So you'll find it. Here, any other corrections is needed? Anything else which has not been covered properly? Right. Fine. One thing is, this will be under root 3 by 2 meters. Under 3 by 2. So here it will be under 3 by 2. So you'll get here by 12. So it will become by 4. So when you cancel it, it will become by 4. So this is very important. Please, a small geometrical mistake will lead you to do the entire wrong answer. Please make sure you don't make this mistake. So the center of mass is, say m is going to be equal to x comma y, that is 3.5 comma 6 upon 6 and under 3 by 4. So that's a very important thing, right? We'll go to the next question now. Continuing with the next question, we have two bodies of masses m1 equal to 10 kilograms, m2 is going to be equal to 2 kilograms, are moving with velocities. The vectors is given here. This is a velocity 2i cap minus the 7j cap plus 3k cap, that is v1, and v2 is minus 10i cap plus 35j cap minus 3k cap meter per second. These are the two velocities. Find the velocity of the center of mass. You need to find out the velocity of center of mass. Now look at this one. This is not position of x1 and x2. It is velocity v1 and v2. Mass m1 and m2 are there, but they are asking for a particular kind of an thing. How it will be the, what will be the kind of center of mass velocity. So I have just already written this one. v1 is going to be equal to v2 is going to be equal to this one, m1 m2. So this is the part which is already given in the question. So one body m1 is going somewhere in one direction in v1 velocity, another body going in another velocity, v2 velocity, m2 is going. So both the bodies are going in this direction, one direction, another direction. It's going to go apart. After some time this will go here and this will go here in different velocity. So now when you draw a line here, this is going to be center of mass maybe, and after some time this is going to be the center of mass maybe, because it's going far apart. So center of mass also will start moving in with one velocity. This point will be constantly moving in its own velocity. Of course this is going in v1, this is going in v2, but what will happen to the velocity of center of mass, in which direction it goes? That's what is asked here. Okay, so try to understand. If suppose this is a huge body going in some velocity and this is a small body going in unknown velocity, we already know center of mass is going to be very close to a huge body here. And if this one starts moving slowly maybe, and this is going very fast, the center of mass will have its own path. We are trying to find out that. So velocity of center of mass, it is same formula. m1 v1 plus m2 v2 upon m1 plus m2. Nothing much difference is there. So 10 kg into the v1 vector 2i cap minus 7j cap plus 3k cap plus 2 into minus 10 I cap plus 35 j cap minus 3k cap upon 10 plus 2, 10 m1 plus m2. Now multiply everything inside, put everything inside, and then divide by 12. Try to do this one. Pause this video, multiply this one, and then add all of them, I cap, j cap. So you will get here I cap and then j cap and then k cap. Maybe plus minus or whatever it is, some number also will be there. Try to find out this one. Once you do this one, after you finish it, you will get 0 I cap plus 0 k j cap, and you will get plus 2 k cap. Not plus 2, it is 24 k cap upon 12. So finally, when you do this one, you will get here as 2 k cap will be the answer. Velocity of center of mass. So that is the velocity meter per second. Going in z direction with the velocity of 2 meter per second. That's the answer. So you get the final answer like this. Okay, this solution comes like this. Right? Now looking at this one, I want you to quickly go into the numericals in the exercise questions. Look at this. Go to the exercise questions. On the other day, yesterday I gave this question as a homework. You would have done it. Now you are going to start with now second question here. 3 point masses, 2 gram, 3 gram, 4 grams are placed at the equilateral triangle. Same thing just now we finished. An equilateral triangle we finished now. So it is 2 gram, 3 gram and 4 gram is here. And The same thing. 1 meter. Now look at this one. We did this. 1 gram, 2 gram and 3 gram. Here what is that? 2 gram, 3 gram and 4 gram. That's a difference. That's the only difference. So this question exactly similarly fits into that one, and even side is 1 meter. So please do this one and you should get this answer. Try this one, right? And similarly, go to the next question also. Question number 4. Particle of mass M1, M2, M3 and M4 are placed in the 4 sides of a corners of a square of length of side L as shown. Shown diagram is already here. So M1 is 2 grams. This is 2 grams. And M2 is again 2 grams. M3 is 1 gram. And M4 is 1 gram. Now 1, 1, 2, 2. Now you need to find out the center of mass. So you will have x1, x2, x3, x4. And you will have also y1, y2, y3 and y4. So you will have 4 parameters. M1, x1 plus M2, x2 plus M3, x3 plus M4, x4. All 4 will be there. Upon M1 plus M2 plus M3 plus M4. Similarly for y also you will have the same. M1, y1 plus M2, y2 plus M3, y3 plus M4, y4. You can find out all the 4 parameters and do this one, you will get this answer. Hope you will be able to do it. Right? So now I'll do question number 3 for you. Look at the question number 3. Read this question and draw a diagram for this. 3 identical spheres A, B and C. These are 3 identical spheres. Each of radius r are placed touching one another on a horizontal table. Where is the center of mass of the system located relative to A? For example, relative to A they are asking. Can you draw the diagram for this? Try to draw a diagram. Make your imagination. Read very carefully. Pass this one and draw a diagram now. Okay, now some of you would have drawn a diagram like this. 3 spheres like this. This is wrong. Some of you would have drawn like this. 3 spheres touching one another. The spheres are touching one another, right? You would have drawn like this. This is okay, but still you can refine this picture. Alright? Maybe some of you would have drawn 1, 2, 3, all 3 together like this. That's also wrong. Okay? Now this is to an extent right, but I would always say draw like this, put an axis and let the first sphere be at the center of this origin here. The next sphere can come like this, same radius, so it can come like this. This is R, here also center, this is R. And the third sphere can come like this, right? And this is also a center. So here this is going to be R, and you extrapolate this one, this is going to be also R. This is going to be R, and this is going to be also R. So you find this entire thing from here to here is 2R. From here to here is 2R. This also is 2R. Okay. So if you take this one as the first one, M1 and M2 and M3. So what is the masses? M1 is going to be equal to M. M2 is also going to be equal to M. M3 is also going to be equal to M. So what is the value of coordinate 0, 0 here? What is the coordinate here? It is from here to here, the distance is 2R. 2R, 0, because y-axis is 0 here. This is x and this is y. And what is the coordinate here? What is going to be here? So you need to find out what is the height of this one from here to here. This is already R. This is already R. X-axis is R. So R, what is the next one? Y-axis. So you can take a triangle here. It is 2R square. This is 2R square hypotenuse minus R square under root. Try to do this one. Tell me what's the answer. So it is 4R square minus R square. So it's going to be 3R square minus R square. Sorry, 3r square of under root. So it's going to be under root 3r. So this is going to be under root 3r, this height. So what is the thing? Under root 3r, you will write here. So what is x1 and y1? 0, 0. What is x2 and y2? y2 is 0, x2 is 2r. x3 and y3, y3 is going to be equal to, what is x3? x3 is going to be equal to this value of r, and y3 is going to be equal to under root 3r. You got it? Quite a nice question, interesting question, simple. X is going to be equal to m1 x1 plus m2 x2 plus m3 x3 upon m1 plus m2 plus m3, and you can write here m into 0 plus m into 2r plus m into r upon 3m. So what will be the answer then? You will get 2mr plus mr, 3mr upon 3m. It is going to be equal to r itself. And what is y is going to be equal to? m1 y1 plus m2 y2 plus m3 y3 upon m1 plus m2 plus m3. So it's going to be equal to m1 into 0 plus m2 into 0 plus m3 into under root 3r upon 3m. So that's going to be equal to, so it's not m3, it is m itself. Okay, m itself. So it's going to be equal to m under root 3r upon 3m. So it cancels out, r by under root 3 you will get. That's why. So what's the coordinate here? The coordinate is r comma r by under root 3, x comma y. That's the center of mass. Look at the answer here. And this is already here like this, same thing. R comma r by under root 3. Okay. So you're also going to do question number 5 and 6. Please do it yourself. Try to do it yourself. This velocity questions already we have done it. Okay. It will be quite easy for you to perform. Then go ahead and try to solve the next question also. Okay, question number 7. Before solving question number 7, I would like to do another question in the exercise question that will help you to solve question number 7. Turn to page number 409 and read this example number 11. In the HCl molecule, the separation between the nuclei of two atoms is 1.27 Armstrong. Find the location of the center of mass of the molecule. A chlorine atom is 35.5 times heavier than the hydrogen atom. So it is showing two particles here. Hydrogen is a small particle and chlorine is a huge particle. This is chlorine. This is Cl. And the two atoms are separated by a distance. This is hydrogen. Is separated by a distance of 1.27 Armstrong. This is the separation of distance. Find the location of the center of mass, where the center of mass is located. Okay. So if this is m, this is 35.5 times of m. So what is m1? Is going to be equal to m. m2 35.5 times of m. And if you see this as the place, and what is x1 equal to 0, x2 is going to be equal to 1.27 Armstrong. It is this much away. Put this in the coordinate system. This is y-axis, this is x-axis, and it is in the 0 point. In x-axis it is in 0 point. Okay. So center of mass is going to be equal to m1 x1 plus m2 x2 upon m1 plus m2. It is only in one axis now. You need not have another axis, just one axis itself. So it's going to be equal to m into 0 plus m into 1.27 upon, this is m plus 35.5 m. So what will be the value? M into 1.27 upon 36.5 times of m. This will get cancelled. 1.27 upon 36.5 Armstrong is the value of x. So if you do the calculation, you will get the final answer. I'll just write the answer. Seeing here, it is 1.235. It's a value here, right? So okay, one mistake I have done. One very important mistake. This is mass m. M2 is this value, no? So m2 is 35.5 m. So it is 35.5 m. So m and m gets cancelled out. So into 30.55 into this much. So when you do the calculation here totally, this much into 1.27, so you get 1.235 Armstrong, you will get. That is x. Okay. Hope you got the idea of it, right? So just one only. You don't have y is equal to a1, m1, y1. You need not do it because it's just in x-axis only. The same way, the same pattern, you will find this numerical which is there in the exercise. Look at this one. The distance between carbon and oxygen atom of a carbon monoxide CO gas molecule is this much. Look at the center of mass of the molecule relative to the one. Now you should know what is the carbon value and what is the oxygen atom. How much is the difference in this one? You know the molecular mass and you should be able to find out this. Alright. So carbon and oxygen atom. You will be able to get this answer also. So next I think you can try solving these two for other three also. 8, 9 and 10 also. It is a homework for you. Please do it. I'll just finish with the last question, which is a very, very important question. This is question number 13. Question number 13. From a uniform disk of radius capital R, a circular hole of radius r by 2 is cut out. The center of hole is at r by 2 from the center of the original disk. Locate the center of mass of the resulting flat body. So let us try to look at how it will be the ways. So I'll read the question again, and it is a pretty tricky question. Please remember, you need to do it carefully. So there's a big circle is there. This is a big circle, and this circle has a radius capital R. And in this radius of capital R, what happened is you have cut down a part of the circle here. This has been cut down. If you cut down and throw it, then this is the rest of the part is remaining. So it is empty here. How much it has been cut down? This is the entire radius from here to here. So what is the cut down portion? It will be r by 2 will be cut down portion. This is O dash and this is O. Alright. So we need to be clear in how do we find out the center of mass of the rest of the portion. Now look at this one. Without this, there's empty space is there. So only this one is there. So what will happen to the center of mass? So let me take you through a very, very clear and important part of it. Listen first of all carefully. We need to first of all put the axis and the origin. Always put the axis and the origin. What did we do here? We were doing even for the whenever we always had an axis, right? So that will always help us to do the right thing. So axis I will always put here like this. You can try to do anywhere also. It's up to you. Don't think this is the only way it is there. This is one y. So if the entire thing is intact without cutting this piece, then it is at the center. This is the center of mass. Now the center of mass will get shifted here. It could have gone somewhere here because this portion is gone. Alright. Now what we'll do is this portion again we'll keep it here itself. We will have this piece also. We'll have two pieces now. This is the cut portion. The cut portion is here. Just keep it in the top itself. Right? And the remaining portion. So first of all, we will say let O be the center of mass of the original body, that is O. Okay. So what is the mass of the entire body? Mass of the original body, it is going to be equal to area into surface density. Area into surface density is mass. Pi capital R square. Surface density, you can put it as sigma. This is called sigma. So that is capital M. Surface density is capital, it is sigma. Right? Now, mass of cut portion. What is the mass of the cut portion? Maybe you can tell small m is equal to pi. What is the radius of this one? The cut portion, what is the radius? R by 2. R by 2 the whole square into sigma. So it makes it here as pi R square upon 4 sigma. That is mass. Now this is the cut portion mass. This is the original mass. What is the remaining portion? What is the mass of the remaining portion? So it is going to be mass of remaining portion is going to be equal to capital M minus small m. That is going to be equal to m dash is going to be equal to pi r square sigma minus pi r square sigma upon 4. So it's going to be 3 by 4 pi r square sigma. That is m dash. Now you will ask, sir, what is this so much of calculation for this mass, big mass and small cut mass and the remaining mass? Why we are doing all these things? Remember, they have not given this is m1 is going to be equal to 3 kg and m2 is going to be equal to 9 kg. That kind of thing they did not give. So what is our main process? This chota circle, we are trying to find out the mass. And in the remaining portion of this, after the cut portion, the remaining portion, we are trying to find out the mass. So if you tell in formula wise, what is m1? So m1 is going to be equal to, in formula wise, if you take this as a tiny cut piece, kept right here itself, fixed here itself, the mass m1 is going to be equal to m pi r square sigma upon 4. m2 is going to be equal to, it's going to be equal to 3 by 4 pi r square sigma. There is no m here. m1 and m2, these are the two masses. Okay. The next thing is, here everything is there in x-axis only. Everything is there in x-axis. No y-axis there. So what is the center of mass here? What is x1 here? So x1 is going to be equal to, for the small piece, it is going to be equal to r by 2. This is the x1. And what is x2 here? It is question mark. I don't know. What is the value here? From here, it would have gone to O dash. Maybe O1. I could say O1 maybe. Okay. From this distance we need to find out. So it's going to be equal to O dash. So here instead of O dash you can say O1 then maybe, okay? O dash if you keep this one. So finally what we should do is find how you need to find out these two things. So it is the balancing of these two things. Since it is the center of mass here itself, we have to balance both of them. So M1 x1 should be equal to M2 x2. I will say one thing. Okay, x is going to be equal to M1 x1 plus M2 x2 upon M1 plus M2. This is the usual way we do it, right? What is center of mass already? The whole big mass. The big mass, two the bodies together, the big mass is already 0. 0 is going to be equal to M1 x1 plus M2 x2 upon M1 plus M2. So this one whole thing gets cross multiplied, it becomes 0. So M1 x1 equal to minus of M2 x2. Right? Now put all the values here. We have everything. So pi r square sigma upon 4 into x1 is r by 2 minus, what is M2? 3 by 4 pi r square sigma into x2, that is x2 is O dash. So this entire thing gets cancelled, 4 gets cancelled. So what is O dash? O dash is going to be equal to minus sign of r by 6. 3 gets down, r by 6. So that's the value. O dash has to be found out. X2 is from here to here, it is r by 6. We have got the answer. So it is pretty easy to say that there are two bodies are there, the tiny circle body and the rest of the body. So we need to try to balance both of them. This is already having a center of mass here, that is, it is going to be r by 2 is the distance. And this one, where it is, we need to find out. So here we need to find out this one. x2 is the question mark, x2 is question mark. What is x? It's already equal to 0. So we have put 0 here. And then we got the value of x2. x2 we got it here. And that is the value of r by 6. So you get this answer through this. So for this, you finally find out the answer is r by 6. They've done in some other way, but I have done in a little different manner. You will find the same question is there in 5 also. So you will have question number 5 also. It is there in the different competitive examination. You will find the same question is there in question number 3 also. These are all in different times they were asked here, but it's quite similar questions. Okay. So anyways, that question already it was there in the book and we have done it. With this, center of mass gets over. Please do all the exercise questions and I hope you will be able to finish it. If you have any doubts, please ask me. But at the end of the class, I would like to remind you one very, very important part is balance your life, keep God in the center and try to find the center, define your center. It will be a blessing. Wish you all the best. God bless you.